We're going to work on a problem from ALEKS that deals with finding atomic mass from isotope mass in natural abundance. So this problem comes directly from ALEKS, and the story problem says that there's a spacecraft that goes to a make-believe planet and collects samples of isotopes. Our job is to figure out the average atomic mass of these isotopes and its atomic number. There is a table in the story problem that gives us the name of the isotope, its mass, and its relative abundance. So we're going to start off with our given information, and we're going to start off with the first isotope, which is tin-120, and we're going to multiply its mass by its relative abundance. Its relative abundance is 95.4%, but we have to convert the percent to a decimal. We can do this by dividing by 100 or just moving the decimal 2 places to the left. We're going to do the same thing for the second isotope. 116.9 times 4.6%. Remember to convert the percent to a decimal. We're going to divide by 100 or just move the decimal 2 places to the left. We're going to use all the digits that our calculator produces because we cannot round too early. But we're going to keep a mental note of our significant figures. So in the first set of parentheses, we are multiplying numbers. We're going to go with the fewest significant figures, but we can't actually round, so we're going to keep a mental note. So I'm going to underline the third significant figure. In the second set of decimals, 0.046 is only 2 significant figures, so I'm going to underline my second digit. I'm going to keep going with the math, and I'm going to add these two numbers. Now when I add numbers, I look at the fewest decimal places. So I've underlined the 4 in the first number, and that indicates no decimal places. In the second number, I've underlined the 3, which is the first decimal place, so that means my final answer should have no decimal places. So I'm going to underline the 9, and I'm going to look at the number next to it. So the 9 gets a score, so my answer is 120 AMU. Now for ALEKS, they do want you to put that decimal, so the next step to do is to go ahead and put the answer in my symbol box. So SN is the name of the element. I'm going to put the average mass on the bottom, and then I'm going to take a look at the periodic table, and I see that tin has an atomic number of 50. That goes on top. Let's take a look at another example. Same type of example, a spacecraft goes to a make-believe planet and comes back with samples of an isotope. Our job is to figure out the average atomic mass and its atomic number. I always want to start off with my given information. So for my first isotope, I'm going to multiply the mass by the relative abundance, and I'm going to use all of my digits that the given problem states because I don't want to lose my significant figures. So 92.0 has 3 significant figures. I'm going to convert that to a decimal, 0.920. I'm going to do the same thing with my second isotope. 8.0 is just really 0.080. I'm going to put this in the calculator. And I want to keep a note of my significant figures. In my first parentheses, the fewest sig figs is 3, so I'm going to underline the third digit. In my second parentheses, 0.080, that only has 2 significant figures, so I'm going to underline my second digit. I'm going to go ahead and add these numbers up. Now I want to take a look at my significant figures. When I'm adding up numbers, I look for the fewest decimal place. So 0.8 is the first decimal place. 0.1 is the first decimal place. So my final answer should have 1 decimal place. I'm going to look at the number next to it. I do have to give 9 a score. So my final answer is 101.0 AMU. I have to show that 0.0 because I have to show 1 decimal place. So I'm going to go ahead and put that into the table, 101.0, and the atomic number for Ru is 44. So when you are trying to figure out the average atomic mass, you just want to make sure that you're multiplying the mass by the relative abundance. Don't forget to change that to a decimal. And you want to keep mental notes of your significant figures to the very last step. Good luck and keep practicing.